have it. All right, modern AI-driven security platforms. We're going to mention this repeatedly. I think it actually is a given at this point. Process enormous amounts of security data. That's its big claim to fame. I can mow through a ton of stuff. We're talking petabytes of telemetry from across the environment. Sources would include raw packets, DNS activity, endpoint telemetry, and application logs. AI models analyze this kind of information. They identify patterns and previously unseen threats. Now, again, you can tell it what's bad or not. That's the whole labeled or unlabeled. For example, your models can cluster unknown binaries into new malware families. These types of insights can then drive automated policy updates in your prevention controls. As a result, detection to response times will shrink dramatically, typically from hours to minutes or even quicker. However, if attackers compromise the machine learning system, whole house of cards falls. They can undermine the entire defense stack. So again, garbage in, garbage out. To build a trustworthy AI model, security teams typically rely on a classic data split. This keeps your training, your validation, and your test sets strictly separate. The training set is where the model learns patterns from historical data. The validation set is used during development for sanity checks and model tuning. Now, quick definition, a sanity check, are you even in the right ballpark? Finally, your test set provides a final, unbiased measure of performance of unseen data. A stronger evaluation method is called K-fold cross-validation. In this case, K represents the number of equal data splits, which are also called folds. Fold is simply one portion of the data set. Example, with K equaling to 5, the data is divided into 5 folds. The model is trained multiple times, each time holding one fold out for testing. The remaining folds are used for training. The final score is the average across all runs, producing a more reliable evaluation. This helps detect overfitting when a model memorizes training data but fails on new data. Concept drift is when your real-world data gradually changes over time. I see a lot of drift in my own personal AI use where it just starts getting a little bit outside of the beaten path and you got to rein it back in. It can also expose data poisoning, which is any situation where the attackers manipulate training data to influence your model behavior.